video, we're going to cover the build event protocol and build event timeline view in the bzl-ui to give you a better understanding of what's happening in your build and to drill down on problems if they occur. Okay, so let's get started. We're here in the abzl C++ repository. I'm going to open up the abzl base package and number of CC library CC tests targets. Let's just click the build all button and get started. So just to get oriented, this is overall build progress and status with the elapsed time. We have the standard error from the build being streamed out. We have this build event timeline, which is ordering the events as they come in. And on the right, we have this kind of summary of events categorized by type. So you can click on these to filter them as it's running. If I only want to watch progress events, I can just click on the progress button. And if I want to clear that, I can type EE or clear event filter, and we'll go back to viewing all the events as they come in. And so it's succeeded. We have overall build status and the exit code on the exit code label. The final event that came in was the build tool logs, which contains events information about the critical path. Let's take a closer look at the timeline. So the events are kind of colorized by the type of event, and for actions according to their mnemonic, those colors kind of correlate to the languages in a uniform way. But the operations we can do inside the timeline are: one, by mouse wheel up and down to zoom. If we hover over the top half and hold down and pan, as well as in the lower half, click, drag to create a selection, and you can drag the selection, and as it intersects the events, we'll render them in more detail below here. You can use the menu or the keyboard shortcuts to reset the visualization to clear, reset the zoom, selection, and event type filter. So let's just clear the selection, ES, EZ, reset the zoom and pan. All right, now let's take a closer look at the build event protocol itself. I think this is useful because for a number of reasons. One is it helps you debug your builds faster. It gives you a more accurate representation of what exactly is happening, and it helps demystify what Bazel is doing. I think new users coming onto Bazel, they don't really understand what's happening under the hood, and being able to inspect this kind of information gives you the confidence to being able to wrap your head around the tool faster. All right, so these are the different event types. The started event gives you some general information about the build, including the version, the command that's being issued, and some explicit command line options. The structured command line is, on the other hand, an exhaustive list of flags and settings that are coming from ultimately the environment. So this set of flags is generated by the Bazel client, which typically is the C++ client that comes with Bazel. In Bazel's case, it implements this independently. But these are all of the flags that are coming in. Some of these you recognize, some of these you may not recognize because they're unpublished or undocumented and are only used by the client interface as well. But all of the RC settings, all the parsing of the RC files occurs prior to this, and the state is summarized here, in addition to all the environment variables which come through that interface but are redacted for this sake of this user interface. So being able to inspect the structured command line is useful to give you sort of a very explicit description of what the Bazel server is seeing. Options parse is a slightly more digestible version of that, where just sort of the explicit startup options and command line options are presented. Progress events are fairly self-explanatory. These you're familiar with seeing from the command line and are passed through as is. Workspace config gives you a sense of what the execution route. This can be useful for figuring out where various files that are generated are, and sandboxing. Configuration settings, these are used by so-called makefile targets and makefile substitution. So those are presented here. Configuration, name set of files, these are all the files that are represented in dependency sets throughout your build. I won't go too much into that. And then actions. So the list of actions presented. I find this useful to really get a better sense of what Bazel is doing at any particular time. Each action, lists the target that spawned the action, any important files that were generated by the action, or standard output, standard error, and the mnemonic for the action. These mnemonics are colored by language. Some of these actions have associated command lines, and this can be useful to understand specifically how your tools are being called and what options they are seeing. This can otherwise be somewhat difficult to figure out just from the command line alone. And what we're not seeing here is some test events. We'll see those in a minute. And finally, the build tool logs gives you a critical path, which we are rendering in a sort of a nicer way to give you a better sense of what the bottlenecks in your build are. Let's take a quick peek at testing. So we've built all these targets in the ABSL base repository. Let's go ahead and test. I'm going to type the T key, and testing has started. We're starting to get test results back. We're getting details as well as a list of passing and failing test cases. In this case, they all passed. That's good. The test results event detail gives us information about what test was run, its status, how long it took, and then we get links to the test output files, which is quite handy. If we run this again, succeeds quickly, and we see that all of these test results were cached. And with that, I think we'll call it a wrap. Appreciate your attention. In the future, I'd like to do another video regarding the build event protocol from a developer perspective and look at the protobufs and how the messages are structured. But until then, appreciate your attention. Hope you found it useful. Thank you.